Hello guys, we are looking at lesson 8-1, graphing linear equations. Grab a ruler and a pencil, maybe a calculator, and let's go ahead and get going. Equations are often written in the slope-intercept form, or y equals mx plus b, where m represents the slope and b represents the y-intercept. Hopefully you remember that from, I don't know, a couple months ago, maybe November, December. How do we draw a graph of an equation written in slope-intercept form? Well, what you're going to do is you're going to start by plotting the y-intercept. Then use your slope and follow rise over run. Okay, and then to find the solutions to equations, solutions to linear equations include any points that are graphed on the line. Additionally, an ordered pair is a solution to an equation if when its values are substituted in the equation, it makes the equation true, and that's what we're going to look at today. Okay, so again, let's kind of remember what it looks like if we have y equals mx plus b. All right, in this first equation that we have right here, you have the m, which is multiplying times x, but we don't have a b. So when we don't have a b, we know that the b is equal to 0. So our slope is 1 over 2, and b is equal to 0. We always go to the y-axis, so you might want to label these. Go to 0, also known as the origin, and plot your point. 1 is going to be your rise, 2 is going to be your run. So starting at at 0, 0, we'll rise 1, and we will run to the right 2, and continue to do that. Rise 1, run to the right 2, rise 1, run to the right 2. And if you ask me how many points to make, I'm going to say as many as possible. In fact, I'm actually going to go back to the middle point and go the opposite way. Instead of going up 1, I'm going to go down 1 and go the opposite direction of 2. Down 1, over 2. And I'm going to keep doing that until I run out of room. There's my line, and you can kind of see why it's important to have a ruler on here. The next line, it says we are going to graph y equals negative x plus 3. I want to write that a little better, and I'm going to change my color too so you can see all the different lines on there. I'm going to write this as y equals negative 1x plus 3. In this case, our slope is negative 1, but our slope needs to be in the format of a fraction, so I'm going to make it negative 1 over 1, and b is equal to 3. So we will start at positive 3 on the y-axis. Always start at that last point there. Our slope is negative 1 over 1, so our rise is negative, and our run is still to the right. So that negative sign just means opposite. So instead of going up 1, I will go down 1 unit, but I'm still going to run to the right 1. Down 1, over 1, down 1, over 1. Keep doing that. And you get a pretty good indication of what your line should look like. Okay. And I'm going to label that one line B. Should have named the first one line A, and I forgot. Okay. The last one is y equals 3. So I'm hoping, y equals negative 3, sorry. I'm hoping that you remember that there is no slope. So basically in slope-intercept form, this is 0x minus 3. We have a 0 slope. We'll start down at -3, and we're not going to go up or over any. We're at the y-axis. This is a horizontal line through -3. Okay. And if you want to know, students, this is the Hoy question out of the Beck's Hoy. Go to the y-axis, plot your -3, draw a horizontal line through it. Okay. Now let's kind of zoom out a little bit. It says on number 4, is 6, 3 a solution to the equation in A? Oops, let me write this in here real quick. Okay, so is 6, 3 a solution to the equation in A? How do you know? Let's first of all look at A and see if 6, 3 is on the line anywhere. As I'm looking at it, yeah, 6, 3 is right here. Okay, so yes, it is. I'm going to use the color for that equation. Yes, it's a point on the line. Okay, the second part of our notes said an ordered pair is a solution to an equation if when its values are substituted in the equation, it makes the equation true. So that's what I'm going to do on number 4. We already know that the answer is yes, but I'm going to write the formula down again. We have y equals 1/2 x. It wants to know if 6, 3 is a solution. We already said that it was because it was on that line, but let's plug it in. So just a quick refresher, we know that 6, 3, that's our x value, and that's our y value in an ordered pair. So I'm going to replace the y with 3 and the x with 6. So is that a true mathematical statement? Does 3 equal 1/2 times 6 or 1/2 of 6? And that's yes, because 1/2 of 6 is 3. So 3 does equal 3. So that's how we show it in, by plugging it into the equation. Excuse me. Now let's look at line B. Change my color to green. It says if 10 is 10, -7 a solution to the equation, how would you know? Well, if I look at my graph, I'm going to zoom in. I don't have 10 on there, so on the x value. So I can't tell if it's on there, but if this is 8, 9, 10 would be out here somewhere, and -7 would be down here somewhere. So it looks like it's possible for it to be on the line, but without having the graph going through that point, I'm not going to be sure unless I plug in these values. So let's do that. So my equation is y equals -1x plus 3. I'm going to plug in 10 for x, -7 for y. Go ahead and label those so you can see it. So that'll be a -7, -1 times 10 plus 3. I'll go ahead and multiply -1 times 10. I get -10. So is -7 equal to -10 plus 3? Yes, it is. Because plugging it in makes it true. Okay. Number 6 says give a solution to equation C that you can see from the graph. So we, of course, have our starting point, which was 0, -3. That's the easy one. But if you look on line C, every single coordinate, including the ones in between the ones that I'm picking, is a solution. I mean, you have 4, -3. You have -3, -3. There are tons of them. Many answers. Going back to line A, it says given a solution to the equation in A that you cannot see on the graph. So if I'm looking at the graph, I'm trying to find something, I don't know, maybe out here in this upper right-hand corner or down here in the lower left-hand corner. I'm going to try to pick something in the upper right-hand corner because that's dealing with positive numbers. So I'm just going to use an x value of 12 and see if I can figure out what the y value would be. So I'm going to go back to that equation and say y equals a half x. And I chose 12 because it's not on the x-axis and it's even, and I know I'm trying to find half of a number. So I'm going to plug in, or I'm going to leave y because I don't know what it is, but I'm going to plug in 12 for x. Okay, and what is half of 12? 6, so y would be 6. My coordinate would be 12, comma 6. And again, I just chose an even number because I knew I was going to have to take half of it. Okay, let's take a look at the back side. Okay, so we have an equation that is not in slope-intercept form. Charlotte is given an equation. She needs to create a graph of the equation, but isn't sure how since she's only familiar with graphing in slope-intercept form. Okay. Devise a plan to help her graph the equation in space below. All right, so we're looking at what we need is y equals 3x. Sorry, let me try that again. We need y equals mx plus b. What we have is 3x minus 4y is equal to 12. And I kind of wrote it like that so you can see that I have a problem. I have this 3x on the left side of the equal sign, and I have to move it over here to the right side of the equal sign. So in order to do that, and I'm going to write my 2 steps up here. Okay, so write these 2 steps down. Move x term by adding or subtracting. Okay, so don't multiply or divide. I need to remove 3x from both sides of the equal sign. So I'm going to remove it from over here by doing the opposite of what's there. And I'm going to do this, what I do on one side of the equal sign, I've got to do to the other. Okay, that gives me 0, and I'm going to bring down the minus 4y. Don't forget to bring that sign down because it goes with the 4y. Okay, over here, since the mx term is first, I'm going to make sure that I write that term first, including its sign. And because the 12 is positive, I'm going to put a plus in between. The second step I need to do is either multiply or divide by the coefficient of y. Okay, and what that's going to do, it's going to get that y all by itself, isolate the variable. So right now, y is being multiplied by -4, so I need to do the opposite. I'm going to divide everything by -4. So I'm going to leave that as y, because -4y minus divided by -4 is positive 1y. Remember, slope needs to be in fraction form, and a negative divided by a negative is a positive. So I'm going to get rid of the minus signs and just leave the 3/4 x. And then a positive 12 divided by a -4 is a -3. Okay, now I have my slope-intercept. My slope, let's see, I'm just going to write it over here, is 3/4. My y-intercept is a -3. So I'm going to start at -3 on the y-axis. Okay, my rise is 3, my run is 4. Remember, always run to the right. So up 3/4. There's my point. See if I can do it again. Up 3/1, 2, 4. Yeah, then I'm going to go back to my original point and do the same thing. Down 3/4. Okay, that's as many as I can do. There's my line. Okay. All right, we've got 3 more over here, and they've not done us any favors. None of them are in slope-intercept form, so let's start with the first one. I'm going to use those 2 steps that I have up top. The first step said to move the x term to the other side by adding or subtracting. Since 3x is positive, I'm going to subtract 3x on each side. Okay, that leaves me with a negative 9y. Remember, that goes with the 3x plus 18, and I didn't give myself enough room. Second step is to divide everything by negative 9. And I'm going to erase that when I come back. So that's going to leave me with y equals a negative 3 over negative 9. If you put that in your calculator, you'll see that it simplifies to a positive 1/3 x. And then 18 divided by a negative 9 is a negative 2. So let me get rid of that. Okay. All right, so I'm going to start at negative 2. My rise is 1. My run is 3. Okay, opposite direction. Okay, you don't have to put the stair steps in. But there's our line right there, and that's line B. Okay, let's see if I can write a little smaller on the next one. Okay, I have 6x plus 3y is equal to 9. First thing I need to do is move that x term over by either adding or subtracting. So I do the opposite of what's there. And what I do on one side, I have to do to the other. I'm left with 3y equals negative 6x, because that's got to go first, plus 9. And then I'm going to, second step says multiply or divide by the coefficient of y. And I'm left with y equals, let's see, negative 6 divided by 3 is a negative 2x, and 9 divided by 3 is 3. Remember, I need a slope in fraction form, so I'm going to go ahead and make it a fraction. I will start at 3. I will go down 2 over 1, down 2 over 1, and I'm going to go back to my starting point and go up 2, opposite way 1. Draw my line. And that is line E. Okay. The last one. Let's see if I can move everything in here. I got 4x minus 2y equals 8. Let's subtract the 4x on each side. Okay. Remember that minus goes with the 2y, so I'm going to bring it down. This goes by itself. And 8 is positive, so I'm going to put plus 8. Okay, second step says multiply or divide by the coefficient of y, which is negative 2. So I'm going to divide everything by negative 2. That leaves me with y equals, let's see, negative 4 divided by negative 2 is a positive 2x. And positive 8 divided by negative 2 is a negative 4. Go ahead and make that into a fraction. We're going to start at negative 4. My slope is 2 over 1, so I'll go up 2 over 1. Up 2 over 1. Okay. So what made this page harder was that I had to convert everything to slope-intercept form. Okay, number 12 says, which line above has a solution of 2, 0? Well, 2, 0 is right here. So that's going to be the one we just graphed, which is line F. How do we know? Because it passes passes through the line, or it passes through the point. Okay, also you can check it by plugging it in. Number 13, which line above has a solution of 15, 3? Well, I wouldn't rightly know. If I were to look at the graph, 15, 3, let's see, 15 would be out here somewhere, maybe, and 3 would be up here. So if I were to guess, it would look like it would probably be line D would go through that. So I'm going to guess line D, but I'm going to prove it by plugging it in. So let's see, the equation I have is y equals 1/3 x minus 2, or I could use the original, it doesn't matter which. And I'm going to plug in the value of x for 15 and y for 3. Okay, so you know if you're multiplying by 1/3, that's the same thing as dividing by 3. So 15 divided by 3 is 5. So I have 5 minus 2. Does 3 equal 5 minus 2? Yeah. Okay, so we checked it by plugging it in. Okay. Number 14, list 2 solutions to the line E, including one that cannot be seen on the graph. So line E, let's see. Let's try one that's on the graph. We can pick any of those points that we chose. How about 3, -3? That would be, let's get better color. 3, -3 would be that point right there. Any of these points would do. All right, it says let's pick another one that's not on the line. So one that's not on the line, let's see, our x-axis goes all the way out to 8. Let's try 10, okay? So I'm just going to try 10. So 10 would be out here somewhere. All right, so I'm going to try 10 for x, and we're going to try to find out what y is going to be. All right, so the equation is y equals -2 x plus 3. So y equals -2 times 10 plus 3. And -2 times 10 is -20. Okay, plus 3. And if I were to calculate that, that's going to give me 17, and 20 is larger, so that's a -17. So I could put my answer up here, make that -17. Okay, one other quick note before you get to the prep part. You're going to see some of the prep part questions. Like you might have something, well, you will, it'll be number 1, or the first one. You have y equals -1/3 x plus 4. That negative sign, kick it up to the numerator. So think of it as -1/3x plus 4. That way you can always run to the right. So on the prep work, you're going to have some graphs that are in slope-intercept form. You're going to have others that are in standard form that you have to use those 2 steps up at the top to be able to do that. And then you have another one that's either a horizontal line or a vertical line. If you have any difficulty with any of this, please find Mrs. Bird or myself, and we'll be